Hello, everyone. Thank you for attending this PowerAmerica workshop. I'm Jim Witham, CEO of GaNSystems. Today, I will share with you how GaN has reached its tipping point and how GaN is transforming the world with smaller, more efficient, more reliable, and more cost-effective power electronics. Our industry is poised at the beginning of what well may be the most significant revolution in electric power since electricity was first used to light a few blocks of New York City 150 years ago. Global electricity demand has grown by nearly 33% over the past decade and is expected to grow another 50% by 2050. And at the same time, renewable energy will account for nearly half of global power generation. Power and power electronics are at the center of our world. And here are three megatrends that are driving a real revolution in today's power electronics. First megatrend, the digital economy. The world has turned more digital. Digital equals data. Data equals data crunching, data storage, data transmission. And that means more power. This growth of data has resulted in significant needs for data centers and 5G. And this infrastructure requires more efficient and smaller size power electronics. Second megatrend, electrification. Many devices that weren't electric before are now being electrified, best illustrated by the center picture, the electric vehicle. But there are other examples too. IoT is an example where we are putting sensors everywhere, and sensors need power. And security cameras, and cell phone base stations, and many others. The drive for electrification is driving the need for efficient power electronics. Third megatrend, energy efficiency. CO2 reduction and energy efficiency are driving clean energy, and those systems use lots of power electronics. So three megatrends, all with the need for power electronics that use less energy and use less materials to get the job done. Let's review some of the major contributors and activities in our digital economy. Do you have a minute? Do you ever think about that phrase and what happens today in a 60-second time period? Let me tell you some things that happen in that minute. By the time I finish this slide, the world will have changed subtly, but irrevocably. There will be 267 babies born worldwide, 2 auto thefts committed in the United States, and 116 people will get married around the globe. That's just in the real world. Let's talk about what happens on the internet. In that same 1 minute time period, 4.5 billion users on the internet. TikTok, Twitch, Tinder. I'm more of a Netflix and LinkedIn kind of guy. Huge amounts of data, many powered by devices from PowerAmerica companies. And it's getting bigger and bigger. Data, and hence power, is skyrocketing in many different segments. Let's take a look at just a few. First is IoT, the Internet of Things, where the world is putting sensors everywhere and systems to take action on that data. Today, 20 zettabytes. In 2025, 73 zettabytes, a nearly 4x increase. Another market segment adding to skyrocketing data needs is autonomous vehicles. It's estimated that autonomous cars will generate 4 terabytes of data per day from their onboard cameras, radar, sonar, GPS, and LiDAR systems. If only 10% of today's US drivers adopting self-driving cars, that would generate 40 zettabytes of data annually. The autonomous vehicle, another huge source of growing data. The second megatrend, electrification. Nearly everything we touch, use, read requires power, and the number of devices is rapidly increasing. We can all look at this picture of gadgets and recognize many that we own and use. And there's more to add, like e-bikes and e-scooters. And you'll see on the right-hand side that the forecasted growth of these electronics is fast, up to 5x growth over the next 3 to 4 years. Augmented reality and virtual reality are skyrocketing. Lots of devices, lots of power required. Adding to the electrification list are electric vehicles. Volumes are forecasted to grow significantly, 30x over the next 20 years. growth rates more typical of consumer devices rather than cars, leading to huge semiconductor market growth. And EV growth reduces dependence on fossil fuels, reduces CO2 emissions, reduces greenhouse gases, but increases global electricity demand by 30%. So we need to make sure power electronics are small, lightweight, and efficient. Let's now take a look at how the digital economy and electrification are impacting global demand of electricity and how energy efficiency supports these initiatives. Reflecting back on the third megatrend I mentioned, energy efficiency, the good news is renewable sources will climb to 40% of demand, resulting in global CO2 reduction supported by regulatory requirements and strong consumer demand for sustainability. Now, the not so good news is that 60% of electricity will still be fossil fuel based. Let's take a look at why that's important. Unfortunately, the world experienced a global pandemic that required worldwide lockdown. The COVID-19 lockdown did give us the opportunity to see real time the impact that humans have on the environment. It's clear from these images that we have a challenge and a responsibility to make things better for us and for future generations. To boost energy efficiency and to help make the planet healthier, companies and governments are stepping in. In the data center area, governments recognize that energy, its supply and demand, are strategic to national economies and security. So they have set rules, targets, and plans to increase efficiency of the data centers and their equipment. In automotive, companies have been under regional government regulations for some time and recognize that electrification must be a major part of their strategy. And in the consumer area, we all like to get our Amazon deliveries, but most of those trucks emit CO2. Then there are all the warehouses to be lit up, the robots to do the picking and packaging, along with the computers, all consuming power. Fortunately, some of the big players are taking their own actions, as is shown on this slide. So on the surface, all of this data and electrification looks great, but we must all do our part in reduction of energy loss, our part in reduction of materials used, our part on a reduction of cost, or we could end up in a dark and dreary place. That's why we're here today, to talk about the mighty power transistor and its important place, its primary place in the efficiency equation. This is a really key chart. In the power world, the transistor is the critical component. We all know this, we live it day by day, but importantly, it's our job to make sure the world knows it. First panel on the left, power electronics is ubiquitous. There are power sources and power users, and always in the middle is the power electronics equipment. This can be as simple as the travel charger for your cell phone or as complex as the electronics in an EV. Second, in the middle, there are universal needs for all power systems. Higher efficiency, so we don't waste power as heat. Small size and lightweight to use less materials. Lower system cost. We've all gotten used to our electronics delivering more for lower price with each generation. And higher reliability. Maybe not as important in the digital world, where if your cell phone breaks, you just throw it away and get a new one. But power systems must work, and work for decades, and be safe. High reliability is paramount. Third, on the right, transistors are the key to achieving objectives I mentioned in the middle of this slide. Many well-respected people have called the transistor the most important invention of the 20th century, and it was important enough that its inventors were awarded the Nobel Prize. Bottom line, the power transistor is the most important component, the most important semiconductor in the whole system, and so having the best transistor is critical. We know it, it's our job to tell the world. Market requirements and GaN supplier readiness make now the right time for GaN. On the left, the graphic shows how GaN, silicon carbide, and silicon compare on some fundamental dimensions. As you can see, GaN outperforms both silicon and silicon carbide on those fundamental properties. The biggest differentiator for GaN is that it switches extremely fast. And what results is significant value for customers, which is shown on the right. Efficiency, 4x reduction of the power losses. Size, 4x reduction, size and weight. And lower cost? Why lower cost? Well, electronics that are smaller use less copper, use less aluminum, use less plastic. Electronics that are more efficient can use smaller or even no cooling system. And all of this reduces bill of materials costs. The transition to GaN from silicon is not a unique shift in power electronics. Power transistors have been around since they were first introduced in the 1950s, and this slide shows that evolution. Today, market needs are primarily addressed by silicon MOSFETs and silicon IGBTs. Silicon carbide and GaN are the new materials disrupting the market, just like when MOSFETs and IGBTs took over the lion's share of the market in the 1990s. For silicon carbide, this means being the very high voltage, very high power alternative for silicon. And for GaN, this means being the cost-effective mass market alternative for silicon. We'll take a look at those markets in the upcoming slides. But first, why now? Why is that tipping point now? Two factors have made today the GaN adoption tipping point. First, the technology. We made our GaN devices more reliable than silicon carbide and just as reliable as the best silicon. Reliability is a key for all markets, but especially high-rel, industrial, and automotive. GaNSystems parts are in space, they're racing in Formula E race cars, and they're getting the job done in exacting applications like factory motors. These are the most challenging environments for power transistors. GaN parts have been proven in the field. In addition, product volume is up and costs are down. The last 3 decades of semiconductor manufacturing experience has shown that as volumes increase, economies of scale kick in, learning curves kick in, and costs go down. GaN is no different. For GaNSystems, our second generation parts are smaller and lower cost. Prices have been cut in half for some of our most popular parts, which has resulted in even more increased demand. Some GaNSystem parts have now achieved lower prices than their silicon counterparts. Second, industry megatrends, which we touched on earlier, have been extremely favorable. End markets are pulling for higher power efficiency for greater differentiation. For example, automotive OEMs want faster charging and reduced number of batteries. Many OEMs committing to going fully electric, companies like VW, GM, and Ford. Consumer charger OEMs are looking to make smaller power supplies that charge batteries faster. Data center customers want to pack more compute into a given volume to increase revenues in their data center server racks. So in summary, that's why power electronics is important, that's why GaN is important, and that's why we're at a tipping point. And the analysts agree. It's exciting to be part of an industry that's forecasted to grow from $0 to $1 billion within a decade. With GaN, power system companies making very different products across many very different applications will take advantage of GaN to meet their sustainability targets as well as provide the products we want to purchase and use. So let me show you some of those products and the value they deliver. Today, GaN is used extensively in 5 key market segments, from low power consumer GaN chargers to very high power automotive EVs, and many markets in between. GaN is in space, GaN is racing in Formula E race cars, GaN in consumer, GaN in automotive, GaN in data center and 5G, GaN in industrial, and GaN in renewable energy. In the consumer market, as we wear, carry, hold, and ride with more electronics, none of us wants to carry an equivalent number of chargers. Fortunately, the vision of USB, Universal Serial Bus, has branched out way beyond computer keyboards and mice. Now, consumers want fewer, smaller, faster chargers, and the market has responded with GaN chargers. Here are some highlights of what's changed in the chargers and adapters markets. On the left side, you see chargers for mobile phones and laptops, where efficiencies have increased and sizes have shrunk by 2x. On the right side, you see how adapters for larger laptops and gaming PCs have increased in efficiency and decreased in size, a 3x size reduction. Taking the vision of consumer devices one step further, think about a world without charging wires at all, where wireless charging, delivered in an easy-to-use way, is a reality. Today, there is wireless charging available, but it's not really what we want. Exact positioning, low power, a small jostle, and the charging stops. Wireless Power Transfer 1.0, the first incarnation, doesn't really meet our wants or needs. Wireless Power Transfer 2.0, with its positional freedom in the X, Y, and Z planes, easily achieving high power for fast charge, its ability to charge several devices at once, and no interference from metal objects make this the ideal solution. And let me show you some of the ways companies are using GaN in Wireless Power Transfer 2.0. Here you see applications from 30 watts to 1 kilowatt. Surface charging for gaps up to 200 millimeters or 8 inches, and charging 1, 2, or 3 devices simultaneously. The enable here is GaN, switching at megahertz frequency, providing optimum efficiency and use case flexibility. Moving from consumer electronics to automotive, let's take a look at the applications for GaN in an electric vehicle. Here are the 8 common applications in a car. The most important power electronic systems in EVs are the chargers and the inverters. Here's an onboard charger and what one of my customers has done. They built 4 models, one in silicon carbide, one in another company's GaN, and one with GaNSystems GaN. You can see the results. With GaNSystems parts, 5 times reduction in size and 3 times reduction in loss. And here's an inverter. Another of my customers has publicly shown the cost breakdown of their old silicon inverter versus the new GaN inverter. The cost breakdown is shown on the right. The new GaN inverter versus the old silicon inverter. 1.7 times power density improvement, and power density is critical as it can be used for more space in the car, fewer batteries, or longer range, plus 8% cost reduction. And on the left, the all-GaN car by Toyota. These prototype cars have GaN traction inverters, GaN chargers, GaN DC to DC converters, all using GaNSystems parts. Switching markets, let's look at the data center. Innovation across all electronics markets is requiring more computing, more data, more and larger data centers. The 53 zettabytes of data for IoT devices will require an additional 500 million servers and 5,000 massive data centers. The 40 zettabytes of data for autonomous vehicles is another 400 million servers and 4,000 massive data centers. The growth in AI, machine learning, voice and image recognition will add even more, all of which is rapidly driving up energy consumption, data center OpEx, and data center CapEx, and, if not carefully planned, an increase in carbon footprint. And as all of the major components in the IT equipment will consume more power, the CPU microprocessor uses more power, graphics chips use more power, and memory uses more power, we must think about supplying that power with smaller, lighter power supplies. GaN solves 3 design challenges: increased efficiency, reduced creation of heat by being more efficient with a corresponding reduction in electricity costs, reduced emissions. Every efficiency percentage point increase reduces the need for power, which lessens the environmental impact and reduces carbon emissions. And reduced size, more real estate to add more CPU and more memory components. In data centers, it's very interesting how small size and high efficiency translate into value. The number 1 expense in a data center is the power to run the servers, so decreasing the power losses lowers the OpEx. But power density is more important because it affects revenue and profit. The picture in the lower left shows a standard power supply form factor. The GaN version has 1.5 times more power. Now look at the server racks. With less space needed by the power supply, more servers can be put into a rack. More servers means more terabytes per rack, and that means more revenue per rack. We recently did a calculation with a big mega data center operator, and it came out to be $3 million per year for every 10 server racks. In industrial, 45% of the world's electricity usage is for industry. 2/3 of industrial electricity usage is for motors. So 30% of the world's electricity is used by motors. They're everywhere, and GaN is helping to reduce their impact on the environment. As an example, here's a nice write-up on Siemens' website describing their new microdrive. Beyond the typical advantages GaN enables, Siemens' innovation defined additional benefits: faster motor response time, increased motor lifetime, and lower system costs because of reduced noise suppression when using GaN. And last, but certainly not least, renewable energy. GaN directly impacts renewable energy at its creation and distribution. Here you see a typical residential solar and battery storage installation. And here you see the economic benefits. 4% increase in revenue, 8% reduction in cost, 12% increase in profits, and the system is 30% smaller. I guess it is possible to have your cake and eat it too. So, tying everything together, in our world of more data and more electronics and the need for clean energy and reduced CO2, we must be more frugal with our materials, more frugal with our energy, and more frugal with our money. The existing legacy silicon has run out of gas. GaN is here today, proven value, proven reliability, proven with customers, proven in the field. Now is the time of wide bandgap, and now is the time of GaN. Thank you for your time. Once again, I'm Jim Witham, CEO of GaNSystems, and I'm happy to take a few questions.